In this video, I'll explain about types of functions. If you have not watched the video on functions, I had shared the link in the description box. Please follow that link. Uh, Here in today's video, I'll just take up the first type of function, that is one function, which is also called as injective function. A function f from a to b is said to be injective or 1 if f of x1 equal to f of x2 implies x1 equal to x2. Or in other words, if distinct elements of the set A will have distinct images in the set B, then such a function is called as one function. Means if images are if elements are different, then their images must be different. That should happen for all possible elements, all possible distinct elements. Then only we call such function as one function. Say the pictorial representation through the diagram I have shown here. I have considered a function f from a to b where the elements are mapped in this way: 1 goes to 6, 2 goes to 5, 3 goes to 7, and 4 goes to 9. Here all these distinct elements, 1 and 2 are distinct, their images are also distinct. 2 and 3 are distinct, their images are distinct. 3, 4 distinct, their images distinct. Hence it is a one function. Whereas in the second arrow diagram, 1 goes to 4, whereas 2 and 3 are distinct elements, but they do have the same image. Hence this function doesn't satisfy the condition of one function. It is not a one function. So there are different ways of defining one function. One is this way: images are equal implies elements are also equal. Then or distinct elements will have distinct images. This is also possible, but when we are checking for oneness, we will be using this particular condition, that is f of x1 equal to f of x2 implies x1 equal to x2. So if you want to count number of one functions, like let n of a equal to m and n of b equal to n, a and b are two sets with m elements and b is set with n elements, then number of functions from a to b is n to the power m. This gives you the total number of functions from a to b. Now if you want to calculate number of one functions or injective functions from a to b, the formula is 0 if n is less than m. If the codomain has lesser elements than the domain, then we can't define any one function. Say for example, in this case, codomain is having 2 elements and domain is having 3 elements. So to make it as a function, automatically I am forced to map one of the element to the same image. Hence there are no one functions. Whatever possibilities you check, impossible to have one function. So if n is less than, codomain has lesser number of elements than the domain, then in such cases there is no one function. N is greater than or equal to m. If codomain is having equal or more elements than the domain, in that case the formula is npm. Np is permutation. The npm formula is n factorial divided by n minus m factorial. Using this formula we can calculate the total number of one functions from a to b. Now let us take examples. F from R to R defined by f of x equal to x square. X1, x2 belongs to, I am taking two elements from the set of all real numbers. R means set of all real numbers. I will take x1 as 1 and x2 as minus 1. So f of 1, where 1 is mapped to. 1 is mapped to 1 square, which is 1. Minus 1 is mapped to minus 1 square, that is also 1. Now images are same, 1 and 1. Both the elements will have same image, whereas elements are distinct. 1 is not equal to minus 1. Hence it is not 1. The definition of one function says that if images are equal, elements individual x1 should be equal to x2. That is not happening here. Hence it is not a one function. You can try with any other element as well. Need not be the full numbers. You can try with the fractions also. 2 goes to 4, minus 2 also goes to 4. This shouldn't happen. If distinct elements are distinct, their images must be distinct. They are coinciding here. Hence it is not a one function. Next one is another example. F from R to R defined by f of x equal to 2x. So where all the real numbers are mapped to multiples of 2. Let me take any two real numbers. Then f of with the f of x1 equal to f of x2. This is the formal procedure of proving the given function is one function, where x1 is mapped to 2x1, x2 is mapped to 2x2. 2 cancels, x1 equal to x2. I have assumed that element images are equal. Finally, I arrived at elements are also equal. Hence, this becomes a 1 1 function. You can check with any number, any real number. 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8, 1.1 goes to 2.2, like that. There is no distinct elements having the same image. That possibility will never come. Hence, it becomes an 1 1 function. There is one more test, horizontal line test we call it as, to say that the given function is to check whether the given function is 1 1. This is a graphical method. 1 1 function has only one x value for each y value. And therefore, if a horizontal line passes through a graph more than once, in such case, the function cannot be 1 1. I have examples here. This is the graph of y equal to x square parabola. Now, if I draw a horizontal line through any point of the graph, then this horizontal line crosses the curve at 2 points. So, means at this particular value, x values are different, but their y values are same. That shouldn't happen if it is a 1 1 function. So therefore it is not a 1 1 function. Whereas this is the graph of y equal to x cube. So in this case, this is y equal to x cube. So in this case, if I draw horizontal line anywhere on the graph of the function, it touches the graph exactly at 1 point. Means for two distinct values of x, there is no same image. Therefore, it is 1 1 function. This is the graph of y equal to sine x. See, look at the graph of sine x. Now, if I draw a horizontal line on the graph, it touches more than at one point. Okay, therefore, sine of pi by 2, sine of 3 pi by 2, sine of 5 pi by 2, sine of pi by 2, sine of 5 pi by 2, sine of 9 pi by 2, all these will have same value. Sine of 0, sine of pi, sine of 2 pi, all these will have 0 value. So means distinct elements will have same images in this case. This is one of the tests to confirm whether the given function is 1 1 function, that is using the graphical method. We call this test as horizontal line test. If you draw a horizontal line on the graph of a function, if that line crosses the graph at more than 1 point, then that function is not 1 1. So that is what the test says. So this is all about 1 1 function. I have defined what 1 1 function is, the definition of 1 1 function, and the formal way of proving 1 1 function. I have to assume the images are equal, then we have to arrive at elements are also equal. The other way, the converse actually, the contrapositive of this, if images are not, elements are distinct, then images must be distinct. And I had shared you the formula to find out number of 1 1 functions as well. I hope you understood this video. Thanks for watching.